Welcome. We want to take a look at an example of showing that a function is one-to-one algebraically. We've previously seen examples of observing whether we think it is one-to-one using a graph, and we've been able to show that it's not one-to-one by giving a particular example, and that's perfect. In this case, what we want to do is we want to show that it is using the definition of one-to-one or one of those equivalencies. In particular, we previously said that a function is one-to-one if, let's see here, yeah, well, if the idea that f of x1 equals f of x2 implies that x1 is equal to x2. Now, letters with subscripts aren't everybody's favorite, so using a and b would be perfectly acceptable here as well. So if f of a equals f of b implies that a is equal to b. Now, the thing here is that it's not just that a is equal to, or it's not that a is equal to b and something else is perfectly fine because we have a is equal to b, right? It's that a is equal to b only. That's the only possibility. If a is equal to b or a is equal to something else, then that gives us two distinct inputs that would associate to the single output of whatever that happens to be. All right, so we want to consider the function f of x equals 2x plus 1 divided by x minus 1. This should look familiar to us. Now, this example does take a little bit of work, more than what you might see in other examples. And I wanted to do that because I believe there are some other examples that you've already seen showing that it's one-to-one algebraically that are a little bit easier. And this one might be a little bit more similar to some of the harder problems that you could see in your homework. So I wanted to share this with you. All right, so I want to show that this is indeed one-to-one as we suspected in a previous example. To do so, I'm going to assume that f of a is equal to f of b, and then I am going to show that a is equal to b, and that's it. Not a is equal to b or a is equal to something else. So what is f of a equals f of b? What does that mean? Well, I plug a and I plug b in. So I get 2a plus 1 divided by a minus 1 is equal to 2b plus 1 divided by b minus 1. Now, what I'm really interested in here is solving for a. So I'm going to just hold on to this thing as a number, right? It is a number. So I'm just going to hold on to that as it is and solve for a. So I'm going to consider this my only fraction for the time being. We'll later find that some simplification is necessary, and that's okay. I'm going to multiply both sides by a minus 1 to find 2a plus 1 is equal to this number, 2b plus 1 divided by b minus 1, whatever that number is, multiplied by a minus 1. Now, if I want to get a alone, then I'm going to need to distribute this thing into there. So I have 2a plus 1 is equal to distribute to a, and I'm going to end up with a times 2b plus 1 divided by b minus 1, and then distribute to the negative 1, and I'm going to have simply negative 2b plus 1 divided by b minus 1. What I'd like to do is I'd like to get all of my a terms on the left-hand side and everything that does not contain a on the right-hand side. So I'm going to subtract this from both sides, and I'm going to subtract 1 from both sides. So I will have 2a minus this thing, a times 2b plus 1 divided by b minus 1. And on the right-hand side, having subtracted the 1 from both sides, I will have negative 2b plus 1 divided by b minus 1 minus 1. Here we have a common factor of a on the left, so I can pull off that common factor of a, and I'm left with 2 minus 2b plus 1 divided by b minus 1. Now on the right-hand side, I still have the exact same thing. 2b plus 1 divided by b minus 1, the negative of it, that is, minus 1. So I have a times a number is equal to a number. Do I know what that number is? No, and that's okay. I'm going to divide by this number to get a alone, And I have, unfortunately, this very large fraction that contains fractions. So negative 2b plus 1 divided by b minus 1 minus 1. And I divided by 2 minus 2b plus 1 divided by b minus 1. What I'd like to have is I'd like to have a equals b. And that's not explicitly what I have right now. So I need to simplify this right-hand side to see if it's indeed b, because a will always be equal to b. And the question is it also equal to something else? Now, the reality is, now that I have a isolated, since I don't immediately have a equals this or that, then I should be able to conclude that it's one-to-one. But I do need to have that right-hand side is just b. If it's not, then I've actually likely made a mistake somewhere. I'm liking the way this looks. This will simplify quite nicely. I'm going to multiply by b minus 1 in the numerator and denominator to get rid of this fraction and that fraction. When I do that, I will have a is equal to, when I distribute this here, it cancels out, and I'm left with negative of 2b plus 1. When I distribute it here, I just have the negative of b minus 1. When I distribute this to here, I will have 2b minus 1. When I distribute this here, it will cancel, and I'll have the negative, right? Could it carry that as subtraction? Negative of 2b plus 1. Now I can just simplify that numerator and denominator to find out if this is just b or not. So I'm going to remove the parentheses and then simplify further. So negative 2b minus 1 minus b plus 1, 2 times b, 2 times negative 1, negative of 2b minus 1, my negative 1 and positive 1 cancel. Negative 2b minus b is a negative 3b. My 2b and negative 2b cancel out. Negative 2 minus 1 is a negative 3. The negatives 3 cancel, and I have a is equal to b. Since a is equal to b only, no other things, right? A isn't equal to b or a equal to something else. It's just a is equal to b. Since a is equal to b only, the function that we have is 1, 2, 1. Excellent. And that's what we were looking to show. It took a bit of algebra to get there, and that's fine. Sometimes it takes a little bit of work. Thank you for joining me.